Right. So, hello. Hello. Hello.
Morning, sir.
Good morning. Okay. So whatever we have discussed yesterday, do you have any doubt? Like the last class, any doubt?
No, sir.
No doubt.
No, sir.
Very good. Very good. So we'll start. Before that, Acha, do you know that NBA visit? NBA, do you know NBA? NBA visit
Yes, sir.
कब हुआ था? NBA visit इस टाइम कब हुआ था? हाँ?
কিছুদিন আগেই তো শুনেছিলাম এনবিএ ভিজিট আছে জানুয়ারি
হ্যাঁ তো যাই
মনে হয় জানুয়ারি ফেব্রুয়ারি করে
এনবিএ রেজাল্ট এসেছে ইসি 3 বছর পেয়েছে বুঝলে গতকালকে রেজাল্ট পেয়েছি আমরা আর ইসি 3 বছর 2023 পর্যন্ত এনবিএ পেয়েছে তো তোমাদেরকে একটা ইনফরমেশন দিলাম প্রথমেই ঠিক আছে তো এখন 2023 পর্যন্ত আমাদের এনবিএ থাকলো আর
কি স্যার এনবি কি বটে
হ্যাঁ
কি বটে স্যার
আর এনবিএ
অ্যাক্রিডিটেশন ওকে যারা জানো না তারা ঠিক আছে যারা জানো তাদের জন্যই বললাম এনবিএ অ্যাক্রিডিটেশন সেটা ইসি বছরের জন্য পেয়েছে যেটা মাস দুয়েক আগে ভিজিট হয়েছিল ঠিক আছে সেটা রেজাল্ট এসেছে যাই হোক সেটা একটা ভালো দিক
ভালো খবর
ওকে
ভালো খবর
okay now let us start with the last class where we have end that what I have said that these are the combination we have to take x0 x4 x2 x6 x1 x5 x3 x5 that we have derived from the relationship. Then I said that if we don't remember the previous derivation, then we should how to get this order. Then I said first to write 0 1 2 like that up to 7. Then 0 corresponds to 0 0 0. This is the digital representation of 0 1 2 7. Then I said you reverse the bit. Reverse the bit means if you reverse 0 0 0 it will remain 0 0 0. But 0 0 1 if you reverse it will be 1 0 0 and 0 1 0 it will remain 0 1 0 and 0 1 1 it becomes 1 1 0 1 0 0 it becomes 0 0 1 1 0 1 it will remain 1 0 1 1 and 0 it becomes 0 1 1 and 1 1 1 remains 1 1 1. Then what I am saying that if you reverse the bit in such a case whatever you will get you take this as a combination right x0 x4 x2 x6 x1 x5 x3 x7 right if you remember the previous if you don't remember the previous derivation still you can find this combination right still you can find this combination now this is the example of a 8-point DFT previously what we have done the first of all what is the idea behind this algorithm the idea behind this algorithm is that as we know that computational complexity of DFT is large if we compute direct computation using the formulation x of n wn n k n equal to 0 to n minus 1. If we use this equation for direct computation of DFT, then it requires n into n minus 1 number of addition and n square number of multiplication. So required multiplication and addition is large if we compute directly. That's why we are, and also we said that from the expression of addition and multiplication, it suggests that if it is n is reduced, in such a case, computational complexity will be reduced. Therefore, we have to compute DFT at lower value of n. Then we have to combine those results to get higher value of n. Once you reduce the value of n, that means my signal point has to be reduced because length of the signal has to be less than equal to n. Okay. So therefore, I said that the minimum point that I can compute, that is 2-point DFT. Then 2-point DFT, from combining this 2-point DFT result, I can achieve 4-point DFT. Combining the result of 4-point DFT, I can get the 8-point DFT. Right. Similarly, if we have higher point DFT, again we compute in 2-point, combine them to get 4-point, combine them 4-point to get 8-point, combine the 8-point to get 16-point, and the process will be continuous. And what we claim, and also we have understood from the expression of computational complexity, that is number of addition and number of multiplication, that if n is reduced, then this multiplication and addition will be reduced, and thereby that will reduce the computational complexity. So therefore, with this idea, we have developed this algorithm, decimation in time, DIT, FFT, radix 2 algorithm, because it is the power of 2.
স্যার আরেকবার একটু রিপিট করবেন কথাটা, মানে ভিডিওটা পজ হয়ে যাচ্ছিল।
What I have said, that the basic idea behind this decimation in time first Fourier transform algorithm is that the direct computation of DFT requires large number of addition and multiplication. If it is n-point DFT, then number of addition is n into n minus 1, and number of multiplication is n square, which is large if the value of n is large. Therefore, if I have to compute higher order DFT, then I will do the DFT at lower value of n. Then combining this result of lower value of n, we will get the higher value of n. For example, if I am supposed to compute 8-point DFT, then what I will do, I will compute first 2-point DFT, then combine the results of 2-point DFT, I should get 4-point DFT, and combine the result of 4-point DFT, I should get 8-point DFT. Therefore, this process will reduce the computational complexity in the sense that if I compute at the lower point, definitely my multiplication addition will be less, and thereby that will reduce the computational complexity. That is the idea behind this algorithm. And while deriving this algorithm, then ultimately we have seen, suppose I have given a 8-point signal, then I have to compute in 2-point, means my length of the signal also will be reduced to 2 points. In such a case, what are the combination to be taken from the given 8-point signal? Suppose x of n equal to x0 up to x7. Then what are the combination to be taken for computation of 2-point DFT? That we have identified through derivations, and that says that x0 x4 is a combination, x2 x6 is a combination, x1 x5 is another combination, x3 x5, x3 x7 is another combination. These are the 4 combinations that we have to take, and I have to compute the DFT, 2-point DFT. Okay. Now, this we have seen that v1 on of 0 is equal to x0, that we have derived probably that here v1 on of 0 is x0, v1 on of 1 is x4, and like that v12 of 0 is x2, v12 or v12 of 1 equal to x6. That we have derived in the last class, v22 of 0 and all these things. If we have derived, I have just written the same thing again, that v1 on of 0 up to v22 of 1, that I have written, that's all. Now coming back to this, I have to compute 2-point DFT. Let us compute that. Now v1 on of k, that is n equal to 0 to 1, v1 on of n, w2 and k. Is this expression all right? Is this expression all right?
Sir.
Very good.
Yes, sir.
Therefore, we have computed these 2-point DFT. Now suppose if I write n equal to 0 and n equal to 1, then I will get v1 on of k, v1 on of 0, w2 0, because n equal to 0, this is w2 0, and if it n equal to 1, then v1 on of 1, w2 1. Then I substitute k equal to 0 and k equal to 1. Since it's a 2-point DFT, k will vary 0 to 1. Agreed?
Yes, sir.
Very good.
Yes, sir.
So therefore, I have to calculate v1 on of 0 and v1 on of 1. Then v1 on of 0 means I have to substitute k equal to 0. If I substitute k equal to 0, this is v1 on of 0, w2 0 equal to 1, and v1 on of 1 equal to w2 1, right? v1 on of, sorry, this is 0. This is for k equal to 0 means k w k to the power 0 means it is again 1. So both are 1. So v1 on of 0 plus v1 on of 1. Now v1 on of 0 is x0 and v1 on of 1 equal to x4. So it will be x0 plus x4. Agreed?
Yes, sir.
Very good. So v1 on of 0 is essentially x0 plus x4. Now if you look at v1 on of 1, so I have to substitute k equal to 1. So if you substitute k equal to 1 in this equation, that will be equal to v1 on of 0 into w2 0, same thing. And this will be equal to v1 on of 1 w2 1. So therefore, this will be x0 w2 0 x4 w2 1. Now w2 1 means e power minus j2 pi by 2 multiplied by 1. Agreed?
Yes, sir.
So it will be minus j pi, e power minus j pi equal to cos pi equal to minus 1. So I am writing minus 1 w2 0. W2 0 means I have reduced getting one multiplication. So I'm writing minus w2 0 into x4. This is my expression for v1 on of 1.
এইটাই আমি বুঝতে পারছি না, এটা মানে -w20 এটা কিভাবে হচ্ছে? ওটা আগের দিনও করেছিলাম।
This is minus 1, na? This is minus 1. I'm writing
হ্যাঁ।
minus w2 0. Minus 1 means I'm writing minus w2 0. This is because I'm showing that there is one multiplication involved.
আচ্ছা।
Okay, so one multiplication involved in the process. Okay, so everywhere when we will come across minus, I will put one multiplication sign. So wherever
কেন
there is,
স্যার দিতে
because
হয়
I
কেন?
am saying that there is one multiplication involved to show this. Okay, so wherever it is, I will involve one multiplication. Okay, now if it is v1 on of 0 equal to x0 plus x4. Now similarly, if you look at the v12, v1 to 0 x2, v1 to 1 x4, then if I compute this 2-point DFT, then I should get v12 of 0 equal to x2 plus x6 like that, and v12 of 1 equal to x2 minus w20 x6. Agreed?
Yes, sir.
So I didn't repeat this step because by now you are familiar with these things, because I have given one example and you know very well what essentially a DFT is and how to compute this. So this step I have not repeated, I have written directly. Now again v2 on of 0. v2 on of 0 means you have to see v2 on of 0 and v2 on of 1 x1 x5. Then v2 on of 0 equal to x1 plus x5 and v2 on of 1 equal to x1 minus w20 x5. Okay.
Yes, sir.
Fine. So now v22 of 0, if you look at v22 of 0 is x3 and v22 of 1 equal to x7. So if I write the DFT, if I compute, it will be v22 of 0 equal to x3 plus x7, v22 of 1 equal to x3 minus w20 x7. Agreed?
Yes.
Therefore, 2-point DFT I have computed. So I will not compute DFT anymore because this computation required more multiplication than that. So what I am doing, I have computed 2 points. Now I will use this result to compute 4-point and 8-point respectively. Therefore, I have computed DFT at 2 points. This is a DFT computation using this equation, using the DFT equation. So here I am computing. Next of the stages, I will use the results. Now let us come here. This is the equation we have derived earlier, that this is your 2-point DFT, this is your 2-point DFT for this particular case, but f1 of k is a 4-point DFT. If you remember this result, this I have done earlier. Is it?
Yes.
Fine. Now, in which v1 on of k you know. So I can write f1 of 0 equal to v1 on of 0, w40, v12 of 0 because k equal to 0, but this k will vary from 0 to 3 for a specific case n equal to 8. Agreed?
Yes, sir.
Fine. Then f1 of 0 equal to v1 on of 0 plus w40 v1 to 0. Then f1 of 1, I am substituting k1 of 1. Of course, v1 of 0 and v12 of 0, you know these things, right? These two have already computed. This DFT I have computed. So these values we know. So I can find f1 of 0. Similarly, if I write k equal to 1, I will get v1 on of 1, w41, v12 of 1 corresponds to k equal to 1. However, I already computed v1 of 1 and v12 of 1. These two I have computed. These two I have computed means I can compute f1 of 0, f1 of 1. Agreed? Now, if I write v, suppose k equal to 2. K equal to 2 means I will write v11 of 2, w for 2, v12 of 2. Now, this is a 2-point DFT. So, a 2-point DFT is periodic with period 2.
Yes.
So, if 2 point, so I have written here, say v11 of 2 means v11 of 0. The reason being v11 of k, v12 of k, v21 of k, and v22 of k. These are all 2-point DFTs. And we know, we have derived that 2-point DFT is periodic with period 2. 4-point DFT is periodic with period 4. 8-point DFT is periodic with period n. So period 8, n-point DFT is periodic with period n. So the top point DFT means number of points in the DFT that is periodic with that period. Okay, this is important thing that we have understood pretty well earlier. Therefore, if I now find f1 of 2, this is essentially v11 of 0 plus w for 2 into v12 of 0. These two are already known to me. I have already computed. Therefore, now I have to compute w for 2. So w for 2 equal to e power minus z pi by 4 multiplied by 2, which is equal to minus 1. So I am writing w for 0. Okay. Okay. Now f1 of 3, that is equal to v11 of 3, v12 of 3, w for 3. Now 3 means again 1 because periodic with period 2. 3 means 1 plus 2.
Yes.
It is 1, so it is also 1. And w for 3, if I compute e power minus j 2 pi by 4, 2 plus 1, then e power minus j 2 pi by 4 into 2 pi by 4, 2 into 1. So 4 pi by 4 means this is minus 1, this is remains. So e power minus j 2 pi by 4, which is equal to minus w for 1. W means e power minus j 2 pi. If it is divided by 4, I'll write 4. If it is multiplied by 1, then it is with w for 1. Therefore, w for 3 essentially equal to minus of w for 1. Agreed?
Yes.
Very good.
Yes, sir.
We have understood f1 of 0, f1 of 1, f1 of 2, f1 of 3. These are all function of v11, 0 and v11 of 2, v12 of 0. So basically it is a function of v11 of k and v12 of k. v11 of k and v12 of k already you have computed during the computation of 2-point DFT. So we know this. Once we know this, I will know f1, f0, f1 0, f1 1, f1 of 2, and f1 of 3. I hope this is all right. No doubts. I hope it's all right. Okay,
Yes, sir.
very good. Similarly, now f2 of k. f2 of k, now it is v21 of k, w for k, v22 of k. This equation I have derived earlier, right? I have derived this equation earlier. If you refer the previous notes, I have derived this. Similarly, the steps we have done for f1, similar steps could be done for f2 because f1 of k and f2 of k both are 4-point DFT, right? Both are 4-point DFT. And in this case, v21 of k and v22 of k, they are 2-point DFT and they are periodic with period 2. Therefore, I can write v21 of 0, w for 0, v22 0 for k equal to 0. So f2 0, f2 1, f2 2, f2 3, I can compute similarly the way I have computed f1 of 0, f1 of 1, f1 of 2, f1 of 3. I repeat, the way we have computed f1 of 0, f1 of 1, f1 of 2, and f1 of 3. Similar way, I can compute f2 of 0, f2 of 1, f2 of 2, and f2 of 3. Agreed? So similar computation,
Yes.
almost similar lines. You have to write only that where it is, it was v11. Just write. This is whatever is there is v11 and v12. Here it is v21 and v22. Rest of the computation are of similar lines. So these things we have not further derived. Okay, just 1 minute. Hello? Hello? Hello?
হ্যাঁ স্যার শোনা যাচ্ছে
Oh.
হ্যালো
So, okay, fine, okay. So these things I have computed. So now my point is, then I have computed that f1 of k and f2 of k. Therefore, now once I have the result, then I can use this equation. This equation says x of k equal to f1 of k plus w8k f2 of k. This equation also I have derived earlier, right? This equation also I have derived earlier. This equation also I have derived earlier. Okay, now if I write, now this k is varying for 0 to 7 because it is a 8-point DFT x of k, x of n having the 8 points. Ultimately, I have to calculate 8-point DFT. So now if I write x0, it is f1 of 0, w80. For using this equation, I have substituted k equal to 0. If I substitute k equal to 1, x of 1 equal to f1 of 1 plus w81 f2 of 1 using this equation. Again, you substitute x2, it will be f1 of 2 plus w82 f2 of 2. Then x3 f1 of 3 w83 f2 of 3. So these 4 equations straightforward. Now if I write x of 4, then it will be f1 of 4 plus w84 f2 of 4. But again, you know that f1 f2 are 4-point DFT. Since they are 4-point DFT, they are periodic with period 4. If they are periodic with period 4, then f1 of 4 equal to f1 of 0, f2 of 4 equal to f2 of 0. Okay, and w84 if I derive, e power minus z2 pi by 4 8 into 4, so it will be 8 pi by 8 z2 minus z pi, again it is minus 1. So I am writing minus. I said wherever it is a minus, I will write w80 to denote that there is a multiplication. So this I will denote w80. Okay, so similar situation, the way I did it earlier, same thing I am doing it here. Now x of 5, that is again equal to f1 of 5, f1 of 5 equal to f1 of 1, because f1 of k is periodic with period 4. Similar situation for f2 of k, f2 of 1, because f2 of 5 equal to f2 of 1, because f2 of k is periodic with period 4, right? So x5, 5 means e power minus j2 pi 4 plus 1, j2 pi by 8 I means these things we have already derived, minus 1, and this is equal to e power minus j2 pi by 8 into 1, and this is equal to then w85 minus 8 minus w81. I hope you understood this step.
Yes.
So I am writing this equal to minus w81. Now if I want to write x of 6, if I want to write x of 6, x of 6 means again you write x of 6, f1 of 6, w86 f2 of k. So x of 6 equal to 6 means 2, and 6 means 2, then w86 equal to minus 8 w2, because it is 2 plus 4 and corresponding to 4, this is equal to minus 1, so w86 equal to minus w82. Agreed?
Yes.
And w87 equal to minus w83, because w84 is equal to minus 1. Therefore, I have got x5, x6, and x7, that is equal to f1 of 3, f2 of 3 minus w8 into 3. So in this equation, f1, f2 are known, so I can find x1, x2, x3 up to x7, because these are all function of f1, f2, f3. f1, f2, function of f1, f2, f1, f2, 4-point DFT, already they are computed, calculated. Therefore, I can obtain x0, x1 up to x7. So this is similar to that. So what my point is that I have computed only 2 points, but what have we got? We have got 8-point DFT. Okay, then we come to the other issues of multiplication and that. Now, we will now plot this data using butterfly structure. This structure is known as butterfly structure. Okay, so now if you look at that v1 of 0, so v1 of 0 is essentially, if you look at here, v1 of 0, v1 of 0 essentially x0 plus x4 and x0 minus w20, that is v1 of 1. So v1 of 0 equal to x0 plus x4. Now let us come there. So what I have done here, first what I have done, I have written x0, x4 here. Now I have v1 of 0, so x0 is coming from here, and w20 is essentially 1, w20 into x4, that means 1, so this will become x0 plus x4, right? And this plot, w20, I am giving one multiplication here, so this is coming x0, and this w20 into x4, this term will come in here. So this corresponds to this term, v1 of 1. So if you look at that v1 of 0 and v1 of 1, this term is computed. v1 of 0 is essentially x0 plus x4, and this is equal to x0 and minus of w20 into x4, like this. Is it okay? Is it okay?
Yes.
First structure. Anybody having any doubt, you can ask. Nobody having any doubt.
W20 টা ওই আগে দিয়েছেন, তাহলে তো ওইখানে V110 তে ওটা ইন্ডিকেট করে
যাক
দেখাচ্ছে।
যাক কোনো অসুবিধা নেই, W20 তো 1,
আচ্ছা, হ্যাঁ
যাক কোনো অসুবিধা নেই। কিন্তু আমাকে একটা জিনিস মাথায় রাখতে হবে যে x4 এর সঙ্গে কিন্তু একটা -1 W20 মাল্টিপ্লিকেশন আছে,
হ্যাঁ।
সেটা আমি অস্বীকার করতে পারছি না, সেই কারণে W20 টা লিখছি।
আচ্ছা,
That multiplication we have to allow, right? That's why I am doing it. Okay. Now, similarly, once we write the first one, x0 plus x4, if I write x0 plus x4, this step, then rest 4 are same. Rest 4 are same in the sense, rest 4 means x2, x6, again same thing, then x1, x5, again same thing, and then x3, x4, again same thing. So this is the first stage of the computation. Is it okay for all?
Yes, sir.
I hope this is okay. So first stage of computation is over. Now second stage of computation. Second stage of computation, what it says, now I have to compute this, what do you call F1, F1, F0, F1 like that. F0 equal to V11 of 0, W40 V12 of 0, and F1 of 1 is equal to V11. So first F1 of 0, so I'm going to V11 of 0, V12 of 0. What does it mean? So now V11 of 0, see V11 of 0 is here, and V12 of 0. So this line goes here. So if this coming here and this coming here, add, that is F1 of 0. Agreed? Agreed? Then F1 of 1 equal to V11 of 1 coming here, and this is V12 of 1. Okay? See V1, see V1, and this is a F1 of 1. Let us see F1 of 1, that is V11 of 1, W41 into V12 of 1. Let us to look at that. So if it is F1, so it is coming V11 of here, and W41 and V12 of 1. This is V12 of 1. They are multiplied by W41, and that goes to here. That becomes F1. Agreed? Agreed?
yes sir.
Very good. Then F1 of 2. F1 of 2 means what? F1 of 2 means, let us see. F1 of 2. F1 of 2 means V21 of 1, W41, V22 of 1. F1 of 1 the holo. Now F1 of 2. F1 of 2 হচ্ছে V21 of 0 minus W40 into V22 of 0. Okay, that is
F1 of sir, F2 of 1
sorry, F1 of 2, sorry, this one. That is V11 of 0 minus W40, V12 of 0. This one F1 of 2. F1 of 2. V11 of 0, W40, V12 of 0. Right? So let us look at F1 of 2. F1 of 2 here, that is V11 of 0. That is V11 of 0, that is coming here. And V12 of 0 with W4, and minus 1 is here. This is minus 1. So this is F1 of 2. Agreed?
V1.
Agreed? Agreed, or shall I repeat? Achha, F1 of 2. F1 of 2. F1 of 2 is what? Let us see.
V110 minus W40.
F1 of 2. F1 of 2, let us say here. V1 of 0 minus W40, V12 of 0. Okay, তাহলে V11 আর V12 টা নিতে হবে আমাকে, তাই তো? তাহলে দেখো, তাহলে V11, V1, F1 of 2, F1 of 2. দেখো তো কত 0 ছিল না এটা V11?
V110
V11 minus W40, V12 তাই তো? এইটা ছিল F1 of 2. তাহলে দেখো V11 of 0 টা কোথা থেকে আসছে? তাহলে এখান থেকে V11 of 0 টা চলে আসছে, এলো, আর V12 of 0 টা এখান থেকে এলো, into W40
minus 1
হলো।
আচ্ছা,
ক্লিয়ার? Similarly, F1 of 3. F1 of 3 টা কোথা থেকে আসবে? F1 of 3, if you look here,
V1 of 1
V11 of 1 minus W41, V12 of 1, তাই না? তাহলে কত হবে? তাহলে V11 of 1 এখান থেকে চলে এলো, then W41 minus 1 into V12 of 1. এটা মিলে এখানে চলে যাবে। Agreed?
Yes, sir.
Yes, sir.
তাহলে আমরা f1 of 0, f1 of 1, f1 of 2 and f1 of 3 টা বুঝলাম।
Yes.
Agreed. Now চলে আসুন নিচেরটা। Similarly, f2 of 0, f2 of 1, f2 of 2 and f2 of 3. This 4 is required. Agreed? This 4 is required. Now, if you look at this 4, again same thing. See, V2 on f2 of 0 is equal to V2 on of 0, V2 on of 0 into V22 of 0. If you look at this,
Into W40.
W40, okay, like that. f2 of 1 equal to V2 on of 1, W41, V22 of 1, like that. V2 on of 0, f2 of 2 equal, like the way we have computed f1, similarly we can compute f2. Agreed? This section, second
Yes,
stage.
sir.
The way we have computed f1 of 0, f1 of 1, f1 of 2 and f1 of 3, similarly we can compute f2 of 0, f2 of 1, f2 of 2, f2 of 3. Agreed?
Yes.
Yes, sir.
Very good. Now let us look into that. X is essentially x0 equal to f1 of 0, w80, f2 of 0, and x1 equal to f1 of 1, w81, f2 of 1, like that, x1, x2, x3. So x is essentially f1 of 0, x0 equal to f1 of 0, then w80 into f2 of 0, right? W80 into f2 of 0. Agreed? Similarly, if I have x1 equal to f1 of 1, then w81 into f2 of 1. Similarly, that is w2 into f2 and w3 into f3. That is your x0, x1, x2, x3. See, x0, x1, x2, x3. So f1 of 0, f2 of 0, w80, f1 of 1, f2 of 1, w81, f1 of 2, f2 of 2, w82, f1 of 3, f2 of 3 and w83. If you look at this third stage, x0, x1, x2, x3, that looks like this. This is x0, this is x1, this is x2, this is x3. Agreed? Agreed? Now, if you compute x4, again, hello? আমি একটু ক্লাসে আছি, পরে ফোন করো। Okay, so now x0, x1, x2 and x3, these are the 4 values we have computed. Now x4, if you look at x4 equal to how much? x4 equal to this, f1 of 4, w84, f2 of 4, and this is periodic with 4, so f1 of 4 equal to f1 of 0, f2 of 4 equal to f2 of 0, and w84 again equal to minus 1. W84 means e power minus j2 pi by 8 into 4, so e to the minus j pi, this is equal to minus 1, right? And w85 equal to minus of w81 using 4 plus 1, and w86 equal to minus w82, and w87 equal to minus w83. This is a similar lines of calculation that you can derive earlier also. Agreed?
Yes, sir.
Yes.
Okay, then x4 onwards, what will happen? f1 of 0, f2 of 0, only negative sign. Similarly, x5, x6, x7, all are having one negative sign. If you look at here. Now, if you look at that, x4 equal to f1 of 0, that is coming from here, and f2 of 0, that will multiply by w80 and minus 1, that will goes there. x5 also same thing, f1 of 1, f2 of 1, then w81 and minus 1, like that it will goes. Okay, therefore what I am saying, entire FFT what I have discussed within the derivation of our last 2-3 classes, entire thing is in this diagram, right? All derivations of maybe probably 100 equations, they are all within one single diagram. So if you remember this diagram, that will be good enough for solving any 8-point DFT. An exam, there will be no question beyond 8-point DFT. Maximum up to 8-point DFT questions will be there. The derivation will be required some part for writing short notes on FFT. That part is required, but solving problem, you require only this diagram, nothing else. No derivations, nothing. Only you require this diagram and you have to compute, of course, v1 of 0, this equation. That also not required, only by this diagram also you can get these equations. So once you remember this diagram, you can straight away start with this diagram and solve any problem of 8.80. So you may forget all this derivation also, but how this come, that suggests in the that is suggested in the derivation. Okay. Now coming to the question of computational complexity. Now suppose if you have one butterfly structure, what is there? We have one multiplication here, then I have one addition and another addition. So each butterfly structure, how many addition is there? 2 addition, 1 multiplication. Do you agree with that? Each such butterfly structure, you are having 1 multiplication and 2 addition. Agreed?
Yes.
So how many such structure is there? How many such structure is there in this? You can count by how many minus 1 is there. How many minus 1 is there? 1, 2, 3, 4, 4, 4, 8, 4, 12. So how many minus 1 is there? 12. Huh? 12.
Yes.
So I will be having this kind of structure. How many? 12? 12 such structure?
Yes, sir.
Yes.
So 12 such structure means what is the total number of addition? 12 into 2. Each structure have 2 addition. The total addition is 24. Total multiplication 12. So 8.d by direct computation কত ছিল? Total addition 56. Total addition ছিল 8 into minus 1 56 আর total multiplication কত ছিল? 64. তাহলে এটা রিডিউস হয়ে গেল। তাহলে using this algorithm, my number of addition is reduced from 56 to 24 and number of multiplication reduced from 64 to 12. Thereby, this algorithm reduces computational complexity to a great extent. Because 64 and 12, that means 61 means almost 80%, less than 80%. 80% computation is less. Instead of 64, you are getting 12 multiplication. So this is computationally efficient compared to the direct computation. Agreed? Now, further moving into the discussion, that what I can write, 24 equal to 8 into 3. That 8 into log 2 base 8. Log 2 base 8 means this is how much? 3. Because log 2 base 2 to the power 8 into 3. So for n equal to 8. So what I can write in general, total number of addition is written n log 2 base n. Instead of n square, addition is 24. 24 corresponds to this. So I am writing total addition equal to n log 2 base n. And multiplication you have got 12, so which equal to 8 by 2 into log 2 base n. So what I can write, total multiplication n by 2 log 2 base n. This is the total number of multiplication. So what I am concluding, so in the process of DIT FFT algorithm, what you have seen that multiplication, which was direct computation, was 64, that now becomes 12. Addition corresponding to direct computation was 56, now it's become 24. Therefore, addition, complex addition and complex multiplication, that are reduced effectively. Therefore, this algorithm is efficient compared to direct computation of DIT FFT algorithm. Okay. If you have any doubt, you can ask. I am having 2 minutes time, or otherwise, I hope you have understood this. Finally, on conclusion, I would like to say one thing, that entire algorithm and derivation, what we have learned, that is for learning, but for solving problem, I require this diagram for FFT for solving any problem. I will discuss example next class. So once we know the diagram, I can solve any problem, and this diagram also very easy to remember, because I said that X0 export, this combination that you can remember using that bit reverse order. So bit reverse order procedure, I can always write this equation, x1, x2, x6, x1, these things I can write for bit reverse order. I can always draw this diagram, because I have to draw first 8 lines, then I have to make cross between 2 lines, and I would write. Tell me.
স্যার বলছিলাম যে যে না ওই আগে যেরকম রিলেশনটা ছিল না এডিশন মাল্টিপ্লিকেশনে, যেটা একটা n স্কয়ার একটা n ইনটু n মাইনাস ওয়ান,
হুম,
স্যার এই কম্পিউটেশনাল কমপ্লেক্সিটিতে রিলেশনটা কি এডিশন আর মাল্টিপ্লিকেশনের?
এটা দিলাম যে এই যে রিলেশন হচ্ছে n log 2 base n,
আচ্ছা আচ্ছা
আর এটা হচ্ছে কি রিলেশন হচ্ছে n by 2 log 2 base n, that is multiplication.
আচ্ছা আচ্ছা ঠিক আছে।
Okay. This is the new relation of this algorithm. And what I am saying that algorithm derivation is little larger because many places, but definition of derivation may be little large, but what I say that there are steps are almost same. So if you derive one step, I can derive other step. Is that it? So I hope you have understood. I will send this note, you read this note, and I will solve one or two problem using this diagram next class. Probably I have less than 1 minute, so I would like to stop here. So I hope you have understood this lecture, and